Welcome to PSMP Pro Notes, where we simplify community medicine for easy learning. Whether you're just starting or need a quick refresher, we've got you covered with clear and engaging content. Let's get started. Hit subscribe and the bell icon for more content and check the description for notes. And welcome. In today's video, we'll be diving into the concept of nested case control studies, a specific type of case control study conducted within a defined cohort. This type of study is widely used in epidemiology to investigate the associations between risk factors and outcomes, especially when the outcome of interest is rare. Let's break it down step by step. What is a nested case control study? A nested case control study is a study design where a case control study is embedded within a larger cohort study. The cohort is followed over time, and cases, those who develop the outcome of interest, and controls, those who do not develop the outcome, are selected from that cohort. This design allows us to study associations between exposures and outcomes efficiently, while ensuring that the cohort data already collected during follow-up is used effectively, minimizing the need for additional data collection. Key features of a nested case control study. Cohort basis. In a nested case control study, the study is nested within a larger cohort that has already been followed over time. This means that the cases and controls are selected from the same cohort, which is beneficial for ensuring a fair comparison and minimizing biases that could arise from using external controls. Case selection. The cases are individuals within the cohort who develop the disease or outcome of interest during the follow-up period. For instance, in a study on lung cancer, the cases would be participants in the cohort who were diagnosed with lung cancer over the study period. Control selection. The controls are randomly selected from the same cohort, but they do not develop the outcome during the follow-up period. These controls are then matched to the cases based on specific criteria, such as age, sex, or time at risk. Matching helps to reduce confounding variables and ensures that the comparison between cases and controls is meaningful. Exposure assessment. Exposure data is typically collected at baseline or during follow-up, before the disease outcome develops. This is a critical feature because it minimizes recall bias, a common issue in traditional case control studies where participants may not accurately recall past exposures. Advantages of nested case control studies. Efficiency. One of the major advantages of a nested case control study is its efficiency. It is cost-effective and time-saving because you only analyze a subset of the cohort rather than the entire group. By focusing on just the cases and controls, this study design reduces the resources required for data collection. Reduced bias. Since cases and controls come from the same cohort, selection bias is minimized. Additionally, the temporal relationship between exposure and outcome is clearer because we already know when the cohort was exposed and the outcome developed later. Check. Data availability. Nested case control studies often have access to pre-existing data, such as baseline surveys and medical records, which reduces the need for extensive new data collection. This can be particularly beneficial when studying diseases with long latency periods. Feasibility for rare outcomes. This study design is particularly useful for rare outcomes as cases accumulate over time within the cohort, allowing researchers to study outcomes that might otherwise be difficult to track. Disadvantages of nested case control studies. Limited generalizability. One of the main disadvantages is that the results may only apply to the specific cohort being studied. The findings may not be easily generalized to other populations, especially if the cohort has unique characteristics. Potential for misclassification. Exposure data collected at baseline may not account for changes in exposure over time. This is especially problematic if participants' exposure status changes during the study period, leading to misclassification of exposure status. Matching challenges. Matching cases and controls is not always straightforward. Overmatching can occur, where cases and controls are too similar, obscuring true associations. Researchers must ensure that the matching process doesn't interfere with the identification of meaningful differences between groups. Survivor bias. Another limitation is survivor bias. If cases are detected late in the follow-up period, controls who died earlier might not be represented, potentially leading to biased results. This can distort the comparison between cases and controls. Steps in conducting a nested case control study. Now let's take a look at the specific steps involved in conducting a nested case control study. Define the cohort. The first step is to establish the cohort population and follow it over time. The cohort should be representative of the population you're studying and be free of the disease or outcome of interest at the start. Identify cases. Next, identify the cases from within the cohort, individuals who develop the outcome of interest during the follow-up period. For example, in a study of lung cancer, the cases would be those who are diagnosed with lung cancer. Select controls. Select controls from the same cohort, individuals who did not develop the disease during the follow-up. It's important to match the controls to the cases based on criteria like age, sex, or exposure time to reduce confounding. Assess exposure. Once cases and controls are identified, exposure data is retrieved from baseline records or follow-up data. This might include information about lifestyle factors, medical history, or environmental exposures. Analyze data. Finally, the data is analyzed using methods such as conditional logistic regression to calculate odds ratios, ORs, and assess the association between the exposure and outcome. Let's consider a study objective, examining the relationship between smoking and lung cancer. Here's how the study might look. Cohort formation. A cohort of 10,000 individuals is followed for 10 years. Cases. 200 participants develop lung cancer during the study. Controls. For each case, 2 controls are randomly selected from the cohort who did not develop lung cancer. Exposure data. Smoking history is assessed using baseline surveys. Analysis. Conditional logistic regression is performed to calculate the odds of lung cancer associated with smoking.